December 25th will bring many reasons to celebrate. It's an annual festival commemorating the birth of Jesus Christ, but in astronomy, that day is also the 2-year anniversary of the launching of NASA's James Webb Space Telescope, humanity's greatest space-based observatory of all time. Launched on Christmas Day 2021, James Webb has been our cosmic workhorse, revealing the universe in a whole new light with unprecedented resolution and wavelength coverage. To celebrate its second birthday, James Webb has just left astronomers feeling festive recently, as it allowed them to image a distant colorful cluster of galaxies they have dubbed the Christmas Tree Galaxy Cluster. In this cluster, the James Webb Space Telescope discovered flickering Christmas lights in the form of 14 new transient celestial objects that brighten dramatically before dimming. Officially called MAX 0416 and located about 4.3 billion light-years from Earth, this winter wonderland was spotted by teaming up the James Webb Space Telescope with the Hubble Space Telescope. The sheer number of transients spotted in one go, thanks to the duo, implies there are many more yet to be found within the Christmas Tree Galaxy Cluster. It's almost like the Christmas gift for astronomers that'll keep on giving. The light from the Christmas Tree Galaxy Cluster began its journey across the cosmos when the solar system, now 4.6 billion years old, was newly formed and just around 300 million years old. This would ordinarily make it too faint for even the Webb telescope to see in detail, but a little trick first acknowledged by Albert Einstein made observing this cosmic Christmas a little easier. In his 1915 theory of general relativity, Einstein said objects of great mass must warp the very fabric of space and time, giving rise to a curvature we experience as gravity. When an object passes between Earth and a distant light source, the light from that background object takes varied paths, causing it to appear amplified from our vantage point. The concept is called gravitational lensing, and James Webb has been tapping into this phenomenon with great success to see some of the universe's earliest glimmers. Its view of the Christmas Tree Galaxy Cluster is its latest example. The transients were found by Yen and the team as they were looking at 4 sets of images captured by James Webb over around 4 months as part of the James Webb Space Telescope's Pearls G176 program. The team has identified 2 objects in the images as supernova explosions, thrilled by this result as they now use those supernovas to study the galaxies in which they are happening. Moreover, the astronomers also found something else extraordinary in the Christmas Tree Galaxy Cluster. A monster star in a galaxy seen as it was when the universe was just 3 billion years old. They have named the star Mothra, after the monstrous MTH kaiju from Japanese cinema. The galaxy in which Mothra lurks was lensed to around 4,000 times its original brightness. The object lensing this galaxy is currently unknown, but Yen and the team estimate it has a mass of between 10,000 and 1 million times that of the Sun. As Jose Diego, research lead author and a scientist at the Institute of Astrophysics of the Canaries, said, "This is a completely new view of the universe that's been opened by James Webb's image in space. Just a few weeks ago, an image of Cassiopeia A, the remains of a star that exploded 340 years ago, was also unveiled by First Lady Jill Biden as part of a new White House Advent calendar. These images and others follow a long tradition of astronomers and other stargazers connecting the season of light with cosmic phenomena occurring light-years from Earth. But there is genuine scientific wonder involved in some of these festive observations. Unlike the Christmas Tree Galaxy Cluster, Cassiopeia A is a lot closer to home. Scientists have long studied the violent stellar explosion and others like it to figure out their role in cosmic evolution. They help galaxies grow. Danny Milovich, an astrophysicist at Purdue University who studies Cassiopeia A, wrote in an email, "Supernova remnants also create the elements needed to sustain life, like the oxygen we breathe, the iron in our blood, and the calcium in our bones. At 11,000 light-years from Earth, Cassiopeia A has been observed by a variety of space telescopes in visible, X-ray, and infrared wavelengths, but the Webb's new infrared vision affords a better view." In April, NASA released an image of the supernova remnant using the telescope's mid-infrared instrument. The latest snapshot makes use of the Webb's near-infrared camera, capturing gas, dust, and molecules radiating at warmer temperatures. The pink and orange structures enveloped in smoky material against a glittering backdrop of stars resemble an ornament hanging from a tree branch. As Dr. Milovich said, 2 years ago, Webb launched flawlessly on Christmas morning. At the time, I thought it was the best Christmas gift ever. But the telescope is the gift that keeps giving. What's interesting is James Webb isn't the only observatory sending us Christmas gifts. A distant star-forming nebula that looks like a turkey fleeing a cosmic Christmas dinner has just been captured in a new image by the European Southern Observatory's Very Large Telescope in Chile. The festive photo features the star-hatching clouds of gas and dust that comprise the nebula IC 2944, located around 6,500 light-years from Earth. IC 2944 has a distinctly F-like appearance, so astronomers have nicknamed it the Running Chicken Nebula. In the stunning new 1.5 billion pixel Very Large Telescope image, the wispy gas and dust tendrils of the nebula glow in red, pink, and orange, punctuated by bright blue stars like lights shining on a Christmas tree. The Running Chicken Nebula is about 71 light-years wide and lies toward the constellation of Centaurus. It contains several SEP regions, all of which are present in the new image, which covers a patch of the sky as wide as 25 full moons. The brightest region, which appears as the rear of this cosmic fowl, is known as IC 2948. This area is stuffed with bright gas and dust plumage and punctuated with bright blue light from hot young stars. These stars spread through the rest of the nebula as well, carving this cosmic chicken by emitting vast amounts of ultraviolet radiation, which disperses gas and dust, curtailing further star formation. But some regions of the running chicken, known as Bok globules, are resisting this high-energy radiation and can be seen as dark, dense pockets of gas and dust sprinkled around the nebula. Further up, the celestial chicken is a bright, vertical pillar-like structure called IC 2944, which appears almost like a chicken wing in the process of flapping. Atop IC 2944 is the twinkling star Lambda Centauri, which is closer to Earth than the Running Chicken Nebula, at just 470 light-years away. The star is so bright that it's visible from Earth with the naked eye. In the upper right of the image, two emission nebulas, regions of superhot ionized gas called GUM-39 and GUM-40, make up the head of the running chicken. A further emission nebula, GUM-41, can be seen to the lower right of the image, forming the foot of the cosmic chicken. Completing the new image is a sprinkling of white and blue stars that resemble falling flakes of snow. Each one is unique, individual, and complex as an actual snowflake. Meanwhile, elsewhere in space, to celebrate the festive season, the Hubble telescope also has just gifted us a dazzling, starry snow globe, which resembles something of a wonderland of Christmas lights. The image's subject is the billion-star-containing UGC 891, an irregular dwarf galaxy located within the constellation Virgo, some 7 million light-years from Earth. To create the luminous chromatic effect we see, scientists compiled data captured by the Hubble Space Telescope's Wide Field Camera 3, an advanced camera for surveys between 2006 and 2021. They ran the data through 12 filters that sampled both broad and narrow wavelengths covering mid-ultraviolet to visible red light. The red patches are thought to be interstellar hydrogen molecules, while the sparkles within are older stars in the very background or other distant galaxies so far away they almost appear to be single stars. Truly, we think that seeing shapes in space telescope images, Christmas-related or otherwise, is just like seeing shapes in clouds. It's all open to artistic interpretation, but there's no denying that the images are beautiful, no matter what they resemble. In short, even the cosmos is wishing you a happy holiday. Now, on the threshold of the new year, let's take a quick look at the most astonishing, jaw-dropping James Webb moments from 2023. 1. One of our most distant black holes ever, last month, while combining Chandra X-ray data with James Webb's deep infrared views of galaxy cluster Able 2744, scientists revealed a tiny distant early galaxy with only around 10 to 100 million solar masses worth of material in it. But it was incredibly X-ray luminous, indicating an active black hole of around 9 million solar masses. Not only is this the most distant black hole ever discovered, but it's also our first example of such an extreme mass ratio, where the central black hole is right around as massive as all the stars in the host galaxy combined. 2. New insights of the Crab Nebula. In the year 1054, a supernova went off in the Milky Way galaxy so brilliant and enduring it was visible from Earth for a long period of time. Now, nearly 1,000 years later, we can look in that same region of the sky and find the Crab Nebula, a supernova remnant more than 10 light-years across with a young, energetic spinning neutron star at its core, the Crab pulsar. Whereas Hubble's visible light views highlight various elements and knots of gas that reflect light, James Webb's infrared views showcase the presence of dust, accelerated electrons, and even the carved-out features by the central pulsar's winds and magnetism. The question of the mass mystery, or of where all the supposedly missing material that would have been needed for the progenitor star to explode, may yet find its solution in the still being analyzed Webb data. 3. James Webb's deepest ever view. The James Webb Space Telescope Advanced Deep Extragalactic Survey, or JDS collaboration, has released a fully zoomable, explorable view of their field with various NCAM filters and NPC spectra capable of being overlaid. An enormous set of the objects imaged. Although this represents a relatively narrow field of view in the sky, it contains the most distant galaxy ever discovered so far, as well as a slew of candidate objects that may yet prove to be even farther away. It showcases the incredible reach and variety of what's possible with James Webb. 4. A sneak peek inside the Orion Nebula. Under James Webb's sharp eyes, there are an enormous number of brilliant, glittering new stars still in the process of forming. Some of them shown here are Herbig-Haro objects, massive young stars that are highlighted by stellar outflows. In other cases, there are protostars still in the process of formation, young single and binary stars that have already finished forming, and nebulous regions that even James Webb cannot penetrate. Lastly, there were some surprises, Jupiter mass objects that are members of no stellar system, including a surprisingly large fraction of them that are binary objects. The images are as beautiful as the science is profound. 5. The most distant gravitational lens ever. At the center of this image, a massive compact galaxy is found, located about 17 billion light-years away within this expanding universe. The ring around it with 2 red spots is actually a single, more distant galaxy that's located along the same line of sight as the closer galaxy, but gravity has distorted it into a ring, an example of gravitational lensing. While more distant background lenses have been spotted, this represents the most distant foreground lens, the object actually doing the lensing ever discovered. In the realm of cosmic discoveries, James Webb continues to unveil breathtaking vistas of the universe, pushing the boundaries of our understanding and reshaping our cosmic narrative. From the depths of space to the earliest moments of the cosmos, Webb's observations have offered unprecedented insights into the mysteries that pervade our universe. One of the most remarkable achievements of James Webb is its ability to peer into the distant reaches of space, capturing the light from galaxies that formed billions of years ago. By observing these ancient galaxies, astronomers can piece together the story of cosmic evolution, tracing the origins of stars, galaxies, and even the structures of the universe itself. In addition to its deep space observations, James Webb has also revolutionized our understanding of nearby celestial objects. By studying objects within our own solar system, such as asteroids, comets, and planets, Webb has provided new insights into the processes that shape these bodies and the conditions that exist within our cosmic neighborhood. Moreover, James Webb's advanced instruments have enabled astronomers to study the atmospheres of exoplanets, worlds orbiting distant stars beyond our solar system. By analyzing the composition and properties of these atmospheres, scientists hope to identify signs of habitability or even detect the presence of life on other planets. Beyond its scientific achievements, James Webb has also captured the imagination of people around the world, inspiring awe and wonder at the vastness and beauty of the cosmos. Its stunning images and groundbreaking discoveries have captivated audiences of all ages, sparking curiosity and fostering a deeper appreciation for the wonders of the universe. Looking ahead, James Webb promises to continue pushing the boundaries of our knowledge, unlocking new mysteries and revealing the hidden secrets of the cosmos. With its unparalleled capabilities and revolutionary technology, it stands poised to revolutionize our understanding of the universe and our place within it. As we celebrate the remarkable achievements of James Webb, we also look forward to the discoveries that lie ahead, knowing that each new observation brings us closer to unraveling the mysteries of the cosmos and understanding the true nature of our universe. In conclusion, James Webb Space Telescope has transformed our understanding of the cosmos, revealing the universe in unprecedented detail and shedding light on some of its deepest mysteries. From distant galaxies to nearby planets, from the earliest moments of cosmic history to the present day, Webb's observations have reshaped our cosmic narrative and inspired wonder and curiosity in people around the world. As we continue to explore the cosmos with James Webb, we look forward to the discoveries that lie ahead and the new insights that will shape our understanding of the universe for generations to come.